Good evening, everyone. Welcome to this Python and Data Analytics Internship program of October 2025. Today, we are going to start with session 27 that will be focused on working with categorical data visualization. Okay. Till now, we have seen different type of visualization that we can apply to our data set. Now we have started working with Seaborn that provide us a pre-built set of visualization that are ready to use, and we can bring them in our code and can use it directly on our data set as we want. So today we are going to see what is categorical data visualization. It is a whole different term. It is related to visualization, but uh, you can say it's slightly different, and it's very important when it's come to data visualization. So in today's session, the learning outcomes that we will be covering the topics through that this session are as follows: like identify categorical variables in a data set, how to do that, then understand when and why to visualize categorical data. Okay. Then choose the right plot for categorical analysis. Like we have different types of plot, like bar plot and box plot, violin plot. We will be going to cover these plot in this session only. Then comes create categorical data visualization using Matplotlib and Seaborn. As we know that Seaborn is built using Matplotlib as its base. Okay, the base is Matplotlib, and we have implemented some calculations or some code in it so that we can use pre-built visualization as it is in our basically data analysis. Then how to interpret insights from categorical charts, we will cover that also. So let's start with the first topic, that what are categorical variables. Okay, so categorical variables represent groups or categories, not continuous numbers. Now there might be a question in your mind, okay, we are dealing with the groups till now, then why we need to learn about categorical variables? Actually, this thing covers, like, you have groups inside the groups. You can call them as nested groups. Okay, what if you want, take an example. uh, there is a class, okay, of 50 students or 60 students. For example, we are taking 60 students. Now from 60 there are 40 students whose average marks are like 50, between 50 and 70. Okay, from 70 to 100 there are 10 students. And let's for an example we can take after below 50 there are 10. So we have three groups now in the class. That is the students having low marks, the student having average marks, and the students having uh, basically what we call highest marks in the class. Okay, so now as you can see, if we consider class as a group and we want to plot the marks of that particular class in a graph or in a visualization, then you can use any method that you want. The like you can use bar plot for that, or other things for that. So like you can consider group them also, like, okay, these many we can see how much marks girls are having, how much marks boys are having. The grouping depends on you. But what if in the same graph you want to categorize those a group, like class is a group in itself. Now inside that group you want to categorize the student based on low, average, and topper in this way. Okay, so there comes this categorical variables comes in a big picture there. We will see through the live examples in VS Code also. Like example, we have gender, male and female, product type, electronics, grocery, fashion. So these are some examples of how to like the student example I have given you. Customer segment is student, professional, or senior. So types of categorical variables are of two types: nominal and ordinal. Nominal are those that have no order. like red, blue, green. Okay. They basically, you cannot say that red is the highest, blue is the lowest. Okay. No ascending, descending can be distinguished between red, blue, and green. But ordinal has order, like poor, average, and excellent. If you want to plot them on a graph or a visualization, you will show poor at the bottom, average in the middle, then excellent on the top. You cannot do poor in the middle, excellent in the between, and average on the top. Okay. There is a certain order that you have to follow. Like whether you are plotting them in increasing order from lowest to the highest or from highest to the lowest. It depends upon you. So categorical variables are of two types, no order and has order. Now the question is, why visualize categorical data? Why we need to visualize the data categorically? Okay. First is that easily compare different groups or categories. You can compare like in the class that we are having average, low, and highest marks group. You can easily compare between them using this categorical data or categorical visualization. Okay, the comparison becomes easy. And why we want that the comparison should become easy is because we need to drive insights from the data as soon as our eyes are seeing it at front. Okay, like there is your senior there is a senior person with you, and he has asked you to, okay, this is the data, visualize it and show me the visualization. So as soon as you present that visualization in front of him, and as soon as his eyes catches that particular visualization, there should be a hint or a spark in his mind. Okay, this is what this data is saying. The details you can explain it later, but the person that is seeing the visualization, it becomes easy for him also to understand, okay, what are the differences, how many are getting the lowest marks, how many are getting the average marks, how many are getting the highest marks. Okay, so visualization and the comparison becomes very easy. Second is detect class imbalance. Very important in data analysis and ML. Okay, so how can you detect class imbalance? Like there is an imbalance between students, as we have seen in the example. 40 are getting average, the 10 are getting low, and 10 are getting highest. So there is an imbalance. Why everybody is not getting highest marks? Why everybody is not getting average marks? Okay. Why 50% students are not getting highest and 50% are getting lowest? It can be any imbalance. In this example, I am just giving you for your understanding to make it simple. So, and why we want to detect this imbalance in the data? Because it is very important while you will train the models. Okay, models, what, like you are training someone. Okay, this is the data. Okay, so if you are feeding the data of 40 students, now let's drop a student example. Let's take another example. Like there is a set of data having 100 entries. Okay, 80 entries or 70 entries are pointing out to one particular group. They are favoring that group A, for example. Now 10 of those entries are favoring group B, and the remaining 20 are favoring group C. Now you start training the model. Okay, so what will happen is that we have already told you that the more amount of data, the more accuracy of your model uh, becomes. Okay, so if model is getting data that groups that favors group A lot, then the model itself will start favoring group A. Okay, although there are two groups present, group B and group C, but since it is trained on 70%, 70% on the thinking that, okay, group A is the best group. So what model will do is maximum times model will try to give the output in favor of group A. There is a highly imbalance between the data. So in order to train the model so that there are no biases in the model, what we will do is we will see, okay, if 70 entries are we are feeding and 10 entries we are feeding of this, either we bring more data in favor of group B also to in order to balance group A and group B, or we should decrease the data of the group A in according to the group B and group C. There are two options, but decreasing the data we will not prefer, because if in case we have less amount of data, in case we have more amount of data, that option can be viable. So it becomes very important to detect the imbalance between the model. And in order to detect the imbalance between the data in the entries, it is needed to visualize them categorically. If we will see it, only then we will correct it. If we will not see it, then you will think that everything is working correct. And that leads to logical errors at the end, because you have done everything right, but the output is not coming as you want it to come. Okay, output may be incorrect, although your code will be correct, your pipelines will be correct, your process will be correct, but the output you are expecting, you will not get that if there is a high imbalance between the data. And in order to visualize that how much the imbalance is between the data, you need to visualize through categorical data. Next is simplify complex tables into easy to understand visualization. Okay, visuals. So simplify complex table, because it means that, like, you are having, I have shown you the which data set we used. I think Iris, uh, we use a data set in the previous that are built-in data set with Seaborn. I am not remembering its name. So in that you have seen that there were approximately 300 entries, 400 entries. And what if a data set is far much bigger than this? Like it is having 1,000 entries, 10,000 entries. We will not, in real life, we will not work upon these small set of data. We will work upon large and large amounts of data, 50,000 entries, 100,000 entries, like this. And in that data also, the columns will not be limited to 10, 15, or 16. There can be any number of columns, 100 columns. They might not go into thousands category. But what if you have to think about 100 columns at the same time with the 10,000 rows? Then it becomes very, very difficult. The tables become very, very complex. In order to make it easy to understand, we start applying categorical data visualization. Next is understand which category dominates and which is underrepresented. Like I have given you two examples. One is of class and one is of group A, group B, and group C. So as we can see that group A is dominating, group B is the lowest, and group C comes a slight it in the node in the middle, just above group B. So you can easily say that group A is dominating this particular thing. Or in the class, the average number of students are dominating. Average number of students are 40, they are greater. Toppers and the toppers are less, and the students getting low marks are less. So you can derive insights like this. Okay, there is less amount of students getting lower number. So this class is performing quite well. But many of the students are stuck in average category. They are not able to move to toppers category. So there might be something lagging behind, or the students might need some more efforts in order to promote them from average to uh, toppers category. Or there can be a situation in which almost 50% of the class is getting lowest marks, only 30% are getting the highest mark or middle marks, and the rest are getting the highest mark. So in that case, we can write that, okay, the syllabus, either the teachers or the process or the system, there is something that is not working for the students, because it is very unusual for the whole half of the class to get lower marks. So the performance of class is getting degraded there. Okay, so you can easily understand which category dominates the situation and which is underrepresented through this categorical data visualization. Next is analyze customer behavior and preferences. Okay, it becomes very, very important. Because at the end, you have to deal with the customer, not with the management, not with anything else. So, like, you can easily analyze by categorizing this data in which product of the company the customer is interested, based upon their reviews, based upon their purchase patterns, and based upon their basically spendings. Okay, so it helps us to analyze customer behavior so that we can move our product in that direction. If customers are reporting that okay, this is the thing that should get improved, and the reviews are coming in very high amount, a large amount, okay, then it might be a serious concern. Then you have to look upon it. Okay, also you can easily analyze which category is dominating here also. Okay, like you are selling three products, and one product is getting lots and lots of sales. It means that it is in very high demand between the customers. Okay, so you can open more outlets in order to provide easy access to the customer to come and buy your product. So this becomes very, very easy using visual categorical data visualization. Next is communicate insights clearly to non-technical stakeholders. Like I have seen in, I have said in the first line only. Okay, as soon as you bring the visualization of in front of any person, whether he has a background of technical knowledge or not, whether he has done some visualization earlier or not, he might be a simple person but knows about something like graph and etc. Okay, so as soon as you present your visualization in front of that person is able to drive at least some insights or the basic overview of that visualization. It has a very, very positive impact on it. Okay, then you can make the details uh, present in front of that person in order to give a detailed explanation of your visualization. Your visualization should not be complex. Remember that. You will try to make it as easy as possible in order to represent in front of anyone and they are able to drive insights from it. Okay. It need not be the case like where only you know how the visualization is working, other person is just sitting and listening to you continuously. So that has a very negative impact and that visualization is generally discarded. Okay, sometimes you might not be there in order to explain your charts and graphs. The higher management has to discuss among themselves or in front of some other person. So they will not be carrying you with them always. So once you explain them, they are able to understand it and they can explain further to other persons. Identify patterns and trends across categories. Like I have said in the analyze customer behavior also, we are able to identify the patterns and trends across categories by using this categorical visualization, like which product is getting sold, which is getting degraded, which trend is in present that the youngsters are following, and etc. Next is support business and operational decisions. Okay, once you presented your visualization to the management or your senior or your manager, anyone, or even in your school, in your final year project in front of your teachers. So what they will do is, like, you are working on a real case scenario in a business firm, then you presented that okay, this is how the data is telling, in which way the data is going, whether our revenues are getting increased, whether our revenue are getting decreased, or we are wasting money somewhere else. You have presented the visualization, the management will discuss among themselves. Okay, they will come to some conclusions, and based upon the visualization that has been derived from the data and the discussion between the officials, some decisions are going to be taken and your visualization is becoming handy in there. So it removes a lot of manual labor intensive work just because you have used visualization on your data. So support business and operational decisions. Okay, this is what it meant. Identify outliers or unusual category behaviors. Outliers basically what is minimum, maximum, these kinds of thing. And unusual category behavior, you can say that you were expecting in 2026 your business is going, you or is simply say your stock price is going to increase from 1000 to 1500. But what has happened in 2026? If in 1 year later on you have drive this inside in January today, okay, we are our stock price going to increase from 1000 to 1500. But at the end of the year, what you saw was a very great decline in the stock price of your company or your organization. It went, instead of increasing, it went from 1000 to 500. So it's a very unusual behavior. Although your sales are getting boosted or some things are happening in favor of your company, but an anomaly has occurred. And it has not occurred randomly. There might be a hidden factor behind it, or there are some factors like geopolitical factors, like Trump is imposing sanctions, etc. Okay, so there can be unprecedented factors that comes in unusual category behavior. So you are going to use this kind of categorical data visualization in order to tackle that. Now there are some common plots for categorical data visualization. Like we have seen these plots earlier also. One is bar chart that is used to compare numeric values across categories. We can use Matplotlib and Seaborn. Then there is count plot. Sorry. Then there is count plot, automatic category frequency. Okay, if you want to count basically the frequency of number of peoples like that. So uh, pie chart, percentage sharing distribution, box plot, we will be seeing that in live coding, distribution and outliers across categories. I will be explaining you there only. Then Boylan plot, distribution plus density, all these terms will be going to explain to you. Strip, warm plot, individual data points. Okay. I can explain you here also, but I wanted to explain through a real example. So we will go to VS Code and then see how they work. So let's start with bar chart first. Give me a second. Okay. So let's start with bar chart first. Used for comparing aggregated numeric values. For example, sales by product category. We have seen it so many times. Till now, you might be familiar with it. So now let's see how categorical comparison is being done here. As you can see, each line is represented by different color. So there is a supermarket. Okay, type 1, type 2, type 3. We are considering that there is a group of supermarket. Inside that group, we want our product is selling in how much quantity in particular supermarket type. Like in supermarket type 1, let's say this is supermarket A. This much amount of devices are getting of our company are getting sold in this particular supermarket. Second supermarket, this much is the devices that are getting sold. And in the third, these much are the devices that are getting sold. So you are seeing here categorical data through categorical visualization. Means what you were doing earlier was every bar is represented by the same color or the same category, but here we are using different colors. Okay, and there is no hard coding behind it. You need not to say, okay, first color will be this, second color will be this. It is done automatically by Seaborn. Okay, so we will see with the example. The very first step before doing any coding is Python is to bring the necessary libraries. As we have seen earlier, so we will be bringing Seaborn and then we will be bringing Matplotlib dot Python as TLT. Okay. So today we are going to work with which data set I should call Titanic data set. That are these are the pre-built data sets in wait. So these are the pre-built data sets that are present in Seaborn in order for our practice. So we are going to load data set as we have seen earlier also. Type spelling. Okay, spelling is right. So now let's see if we are importing it or not. There is an error. Matplotlib. Acha, L is there extra. Again, spelling mistake. PL. OT. Okay, this is how a Titanic data set looks like. If you can see, like these are the indexes 0, 1, 2, 3, survived 0, 1, 1, 1, 1. Yeah, these are the number of people that are getting survived. P class is this. Then they are specifying the gender, that is sex, male, female, age, and then these are some things which even I don't know. So fair is this, embark class, third, first woman. I have told you that there can be many columns that are not even of use for us also. Okay, so but in order to give this view that how our data set looks like is basically this: adult male, true false, like this. Alive, no, yes. Alone, false, false, true, whether they were alone or there was someone with them. Okay, so this is how our data set looks like. Now we are able to import our data set in this what we call in our Python program. So now let's see what are the identify basically categorical columns. In order to identify them, we will use select t types, then include equal to object per column COL. Okay. Now what is happening here? Tribute error. This is object. There is a spelling mistake here also. I am not able to identify it. Data frame object is not attribute column. Okay. I will get back to you again by saying why it is breaking here. I think I have done the right thing. But let's go with our bar plot first. SNS dot, or you can use df dot info also. Here you can see like this is object, okay, and this is object. These are the things that we were trying to find out from the above line, but somehow it is not working. So we can use df.info. But only thing is that df.info will provide you all the columns with all data types. But in this particular line, we were trying to extract only the columns having object type, like you can see here, object. Okay, here is object, here is object. Okay, these were the things that we were trying to extract. But we can also see through df.info. Now let's go with bar plot. Bar plot. Then on next axis we are going to use class, and then on y-axis we are going to name it as age. You using column age, then data equal to df. We have stored in it df. Then need to give the title for it. TIP. We are going to calculate the average age by passenger. Okay. Okay. Now let's show PLT. So now you can see our graph is coming like this. This is the simple thing that we were doing earlier also in earlier sessions. But now we want to do it by using hue. What hue is, I will tell you in a detail right now only. But let's see how this graph looks like. Okay. So first class, second class, third class, these are the classes basically based upon like you have AC first tier, AC second tier, AC third tier in trains, in railways. Okay. In trains, you are having that type of class. Similarly, there is a class that first class. In first class, the person that were traveling was of minimum age between 45 or 40 and 35. Okay, this is the lowest value, this is the highest value. So in second class, these many were the people, and in the third class these many were the people. And average age of this third class is like, if you can see, around 25, second class around 30, and of first class between 40 and 35. So these are the insights that we can drive right now from this code. But if you see like plot, okay, let's copy our code only. Now instead of age, we're going to use pair and one variable as hue equal to. Now you can see it here. This is also the bar plot, and this is also the bar. Now what we are doing, trying to do is, we are calculating how much is the fare by class and the gender. Like for first class, female are represented by this orange, male are represented by this blue. Okay. So in the first class, the average male fare was this much and average male fare was this much. It means female were having higher average of fare as compared to males. It can be affected by two factors. Either the number of females were more as compared to number of males, or second can be uh, the price for the ticket of female was higher than as compared to male. Now we are not saying that there is a discrimination between them or not. There can be any other factors also. Similarly, for second class, we are saying that this is male, how much fare for the male average fare, and this is the for female. Instead of fare also, if you want to use age, you can use age also. Now it is representing the age of average age of male in first class. Average age of male in first class is above 40, and average age of female in the first class is between 40 and 30. Similarly, average age of male between second class is around 30. Okay, and average age of female is slightly less in the second class, less than 30. So you can see that average age of females were younger in every class. It means females were younger than the males. Okay, the insights that you can derive from it. So now by using this particular variable hue, you are able to group between the groups. Earlier there was a group named as passenger, but in passenger also there were females and males. Now you are representing them both parallelly in the same graph, and you are able to drive more insights as compared to this earlier graph. As you can see, earlier graph was simple. There is no information about male and female. But this graph contains information about male and female. So there are many things that you can derive from basically this, what I should call mm, categorical data visualization graph that were not present in the earlier graph. Okay. So up now the question is, what is hue? So hue is used to split the data into subcategories using different colors. Okay. So like earlier we were having the data, we are not distributing it between male and female. But now we are splitting that data into even subcategories like male and females. Earlier it was a whole data set of passengers, but now it contains information about male and female. One more thing, hue adds one categorical variable to the plot. Okay, and each category in hue is shown by a different color, as you can see here. So it helps, in short, if I can say, it helps us to compare groups within groups, means nested groups. Okay, so this is how it works. Now let's move to the next example. Uh, okay, now there is a count plot. Okay, we will be going to cover this. We already know that count plot is used to automatically counts category frequency. Okay, and no need for manual aggregation as it is done all automatically by Seaborn. Ideal for EDA, exploratory data analysis, that will be coming after these sessions are covered fully. So, okay, after count, we are having box plot and Boolean plot also. Theory, I'm going to explain you it here, but in detail, I will, okay, here also I will give you the idea. Like box plot and Boolean plot used for comparing distribution across categories, detecting outliers and understanding spread and variation. What it means is comparing distribution across categories, like for example, you can see in the below chart, this is a Boolean plot basically. You are seeing two categories, male and female. So sometimes this curve is getting more spread as compared to the orange curve. Blue curve is getting more spread. Now you can see in the next Friday, if you see on Friday, then this curve is not spreading, it's not widening, but it's lengthening. Okay, its wideness has decreased, but the wideness of orange has increased. Okay, similarly you can see this wideness is greater in here in blue and orange is less wide. Okay, so what it means is that the larger amount of area covered by a particular colored curve, it represents how the data is distributed, means how it is spread across the data set. Okay, the larger, how much data is concentrated in this particular area. Box plot and Boolean plot are same thing only. The only difference is that in box plot we only know that okay, this much is the data, here data is concentrated, and all these things are basically given by us, to us by the box plot. But if you uh, in short, if I can say is that box plot is spread using minimum, maximum, and average value. Remember these three: minimum, maximum, and average. Okay, so there might this is the minimum, this is the this is the minimum, this is the maximum, and this is the average. Okay, so this is how minimum, maximum, average, minimum, maximum, average is spread or given by this box plot. In addition, this is also given by Boolean plot, but in addition to these outliners, Boolean plot shows us how data is spread and where most values are concentrated. So the plot below, that is Boolean plot, is showing us that how data is spread and how much data is concentrated where. Like here in blue, the data is concentrated more as compared to orange. Here orange is concentrated more. Okay, and how it is spreading. So the curve tells us this only. Or the width of the violin means violin plot shows how many values exist there. Wide part means many values. Where the part is wide means there are many values. Most of our data values are getting spread or concentrated in this part. And narrow part shows few values, means it is having less values as compared to this blue part. Okay, so it helps us see where data is concentrated, if I can say it one in line. And violent plot is nothing but it's an addition of density to that distribution. I know it is getting you might be getting confused, but we will see in the example. There I will be explaining you again uh, about this. Uh, okay, let me think an example. Okay, like you are going to or there is a data which contains the spending of customers. Okay, so there is a certain budget that is with the customer. Okay, this much money I can spend on the product or on the things or on the groceries. Okay, so there might be customers that spend around, for example, 300 rupees. Okay, and there might be customers that are able to spend amount rupees 500. But the customer that are able to spend rupees 300 are approximately 1000, and the customer that are able to spend rupees 500 are only uh, like 400 500. Let's consider them as 500 only, or 400. You can means they are less as compared to 300 rupees spending customer. So what will happen is that when we plot this spending data on the violin plot, then the area containing the spending of 300 will get widened, because there are the number of customer there are more as compared to the number of customer that can spend 500. So the area that are having large number of customers will get spread, and that the area that is having less number of customers, it will get shrink or narrow. In simple, we can say like this. And in summary, if you want between box plot and volume plot, we can say is that box plot shows the summary and volume plot shows summary plus distribution, how data is distributed, how wide the curve is, how narrow the curve is. Okay, box plot are easy to read. Okay, but violin plot are more detailed. That's why they become somewhat complex. Okay, so if we consider from our point of view, for beginners, box plot are very good, but violin plot are used should be used for deeper analysis only once you are familiar with this data analysis part. Okay, so this is what box plot and violin plot basically stands for. Now I will show you with examples of count plot, box plot, and violin plot. So like for count plot, you can use count plot. On x-axis, we are going to use sex as gender. Okay, count plot only have one variable, then comma data equal to df plt dot title. If we use count plot without using u, I am going to show you both the ways. Title passenger count by gender. This is the simple count plot. Now let's go with the count plot using u. Let's see which gender survived how much. Means survived. We will use survived variable. Now you can see male survived a lot as compared to females. Okay, sorry. Survived, blue line represents 0 and here represent 1. How many survived? True, false, basically like that. So this is how count plot can work. Now let's see about which plot? Box plot. So this is how our age distribution by passenger looks like in box plot, as you can see here. Okay. So it shows median, spread, and outliers used for comparing distributions basically. And if we see about the violin plot, then it will come like SMS. Now you can see it here. Okay, you can see that both the all the three classes are having different amount of data spent differently, as you can see it here. Okay, so this is how age distribution of class is represented by both bar chart, sorry, box plot and volume plot. Now here what we are doing is that we are only focused on finding the summary like mean, median and max. Okay, so but here it is not it is also showing us mean, median, mean, average and maximum value. But in addition to that summary, it is also showing us how the data is spread here. Okay, so how the data is getting spread is like that. As you can see this leaf pattern here, but here it is like suddenly it goes above, means the data between these entries 20 and 40, as you can see between somewhere, the maximum amount of detail lies here for the age. Okay, the matlab age of the people around 20 per more as compared to around 80 and 60, because the here the area get narrowed, but here the area is very very high. Okay, so this is how things work. You can use hue here also. Now you can see the comparison between male and female data easily. Okay, earlier it was aggregated, but sorry, I made the change in the same code, so we are not able to see the previous volume code. But you can now easily figure this thing out. Okay, how the data is spread, in which age group more number of people were present. Like if you can see in the first class, the age group of people is basically around 40 more, means people belonging to 40 age group were more as compared to people belonging to above 60 group. You can see this is the male data, this is the female data. So here you were only seeing the min and max age and average age and min and max. Like maximum was 80, minimum was like 0 or something. What is it? Okay. So and in violin plot you can see this also. Okay, that provide if I'm saying again and again, earlier it is providing us the uh, mm, summary, but violin graph is providing us summary plus how the data is distributed. And from box plot we were not able to tell which age group the people belongs more. Okay, but through violin plot we were able to identify which age group the people belongs more. Okay, so uh, these are the things that we have covered. Now there are some best practices using uh, best practices that we use to follow categorical visualization. Give me a minute, please. Best practices for categorical visualization are as follows. Use clear labels and titles. We should always use labels and titles in a way that we are able to easily identify what this graph is going to tell us or what things are being compared in it. Rotate x-axis labels if categories are long. Avoid too many categories. Make it as simple as possible. Try to use, if you want to plot different categories, then try to plot them on different graph. Choose readable color platelets, and use percentage where needed. Always label axis clearly. All these things are for good visualization. And not for only categorical visualization, but for good visualization. Good visualization improves through understanding, not decoration. The more amount of the information that you are able to derive from the visualization way it weights more as compared to the decorations that you are putting on it. Don't make things too complex, don't make things too eye catchy. Also make as simple as possible as and informative as possible. So for the assignment, please load the data set. You can use any data set, Titanic retail superstore data, whichever you want, or any open source data set. Create one count plot, bar plot, and box plot and Boolean plot. Okay, see the data set and try to visualize the column that you want. Write two insights based on your visualization, as I have explained you in the graphs, that okay, the age group of 40 people is more as compared to age group of A, or you can compare between the male and female between the first class. Ki, okay, in the first class, the women were more younger than the male and their numbers were high. Anything can be derived from the graph. Try to use different graphs so that you are able to practice more and more. Things comes through practice, not through just uh, reading and memorizing everything. Submit the assignment on this Google form. Then is submit the assignment on the Google form and submit it. For help and support, please contact us here. And thank you for joining today's session.